Okay, this video is about how to use the experimenter. So we have the beginning GUI, Weka GUI chooser, and we can choose the experimenter here. And this is the experimenter. And we're going to learn how to use it effectively in conjunction with attribute selection. So we're going to start with the data set, the credit G data set. So let's open that up. And I'm using that because it has a fairly large number of attributes or variables. And you can see that there are 21, including the class variable. Okay, now let's review how to use the Select Attributes tab here. So we can click here, and you can select. Here we have different attribute evaluators, and these are search methods. So search methods means we're going to try to choose the best collection of attributes from among the 21 or 20. From among the 20, we're going to choose we want to look for the best. And part of the problem is that there's sort of so many different combinations that we could choose. Like if you think about it, suppose we choose just 10 from the 20. So we have these 10 different slots to fill up, and we can fill them with any of the 20. And this kind of problem in mathematics is called counting. And this would be the calculation, or this would stand for the calculation. And this would be the actual calculation. And you can here you can see that you could write. This would, on top, would look like this. On the bottom, you'd have 2 10 factorials. You cancel one of them here and one of them here. And then you'd have this. And this is going to be quite a large number. Here's the formula that we used. And we can click on here. And here's the same formula. And we put in 20 and 10, and we calculate. And so there are going to be 184,000 different combinations, and that's specifically if we chose 10 from the 20, but there are all other ways that we're not necessarily just choosing 10, we're choosing 11 and 12 and so on. So there's going to be so many different combinations. So this search method means when we search through all those combinations, we want to do it in sort of some kind of efficient or organized way. So they have different ways of doing it. We're not going to get into what they are, but you can look them up and try to understand them. But they're searching through all the different possible combinations that we want to test. And then with each one, we want to see, well, we're trying to make an evaluation. How do we order those different combinations of these attributes, say which one is the most important, which one is the second most important, and so on. So that's what we're trying to do here. We're trying to decide, well, which one of these is the most important in predicting the class for amongst all these 20, which one is the most important, which is the second most important, which is the third most important, and so on. Remember, this data set is about predicting whether someone's going to pay back their loan or not, and the class is, are they going to pay it back or not, or do they pay it back or not? Anyway, we're trying to decide which of these are the most important variables. That's what attribute selection is going to help us to try to do. And there are different ways to do this, as well as different ways to search through all of them. So we set both of these. So that I think the default setting is maybe starts up here. And then, but we're going to first look at this one, which is here. And when we choose that, it gives us this message. It says, this is the way we have, this is the search method, I guess the only search method that will work with this attribute evaluator. So we can run this now and see what it says. So we have to choose a class typically. So we'll choose a class, the class variables down here. And we could either use cross-validation or use this, but I think maybe this takes even longer. But anyway, let's just use it the way it is. Okay, and there, it's already done. So now what it says is that the most important variable is the checking status of the customer. And checks are, well, if you don't, in many countries they use checks to make payments. And I guess this is like something to do with the status of someone's checking account. And it seems like the second most important variable is whether the person is a foreign worker or not. And the third most is their credit history. Now, this is not the order that the original variables were given in. Let's see what was the original order. Checking status was first, but duration, credit history, and so on. So it's not following, of course, the same order. We're hopefully getting some good information here. The checking status is the most important. Foreign worker, according to this algorithm, is the second most important. Credit history is the third most important. Duration is the fourth. So the checking status was the first one. Foreign worker was the 20th variable in our list. This was the third. This was the second. But now we're saying these are the most important. And down here, we have the same list. And it says there are 20 of them. So one easy way to do this is to say, okay, well, I just want to choose the first 10 variables. So I'll just choose the first 10. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, goes to 4. So I'll just choose, 4. Okay, and then I'll copy and paste. You can't do that by right-clicking, but you can use the keystroke. So I'll do that. Control copy. I just did that. And now I'll go back to the data. And I will go to here, unsupervised. And we want to eliminate attributes. We're only going to choose the first 10 in there that we saw, the 10 most important. So you go to remove here and click on that. And you can put in the instances. Now, I just copied the ones I want to keep, actually. But you can say invert the selection. So these are the ones right now. I'm going to remove them. But if I do this, I'm going to keep them. But don't forget, I always forget, that you also need to keep the 21st one. That doesn't appear in this list, but we need to keep that as well, the class variable. So you need to add that at the end. And then you can click OK. And now we can run it here. And now we have just the 10 most important variables. Okay, so what you should do you can play with this. You can see how well it classifies. You can try it out with, for example, J48. Before we got 71.2. Let's see what happens. 72.1. So did we do better? Yeah, we did a little bit better. So it did work, actually, but that's not what we're doing here. What we're going to do now is we're going to save this file as a file. So we're going to have a credit file, but only with these variables. So let's save it, and I guess we could leave it in here. I don't think we can actually write. I don't think I can actually write to this folder in my. I'll see if I can, but I don't think I can. I'll call it credit G. I think G stands for German, and I'll call it top 10. But it's the top 10 according to that one algorithm that I use, not necessarily the top 10 according to some other algorithm. So maybe I should call it top 10 info gain. I think that's what it was called. So anyway, but I don't even think it's going to let me write here. So let's see though. Save. I'll check and see if that actually worked. No, it didn't even let me write in here, and Weka doesn't give me a message about that, which is pretty annoying. But anyway, it didn't let me write to there, so I'll do it on my desktop instead. So I'll try this again because it didn't let me write to this data folder, even though it didn't give me a message, but it did at least keep the name here. So I will go back out to to the desktop maybe? Is that the desktop? Okay, and I have to put the name in again. And can I create a folder here? Because I'm doing this for the experimenter. Okay. And I'll put it in there. And let's see if it actually went into there. No, it didn't, because Weka is not so great with all of these kind of Windows type stuff. So I have to give it the right name again. I forgot to give it the right name, I guess, maybe. Okay, let's try it again. I'll see if it works this time. Okay, and finally I got it in there in the desktop in my for experimenter folder, and it's there. Okay, now I'm going to undo what I did. So I'm going to go back to the original data set now. So I'll go to undo, and that gives me all of the original. Now I can go back to select attributes, and I can say, okay, I want to create another that only has the first, whatever this is. I don't know, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so oops, I can't do that. I'll Control C, and I'll go back here, and I'll go here, and I'll try that same thing again. I'll go to here, and I still need the 21 in there, so I'll leave that there. Comma, I have to type in the comma. Okay, and now let's see what happens. I'll click OK and apply it. Okay, now I just have those. Okay, now let's do the same thing. Save. I guess we need some better name for this. But anyways, what was this? The top 1, 2, 3, 4, 5, 6, 7, 8. Okay, top 8. Okay, and I'll save it again. And let's see if it's actually in there. If that actually. Okay, I also have that one in there. And just for fun right now, I'll just run it. This is not part of what I'm trying to do, but let's just see what happens. Okay, actually, it even got better. Interesting. So to me, this is very anti-intuitive. That is, we're removing information here, right? Now we only have so many variables here, and yet we're getting better predictions. So that's very unintuitive to me, but it seems to work. Okay, now let's just try another. For example, let's see what this one does. Click yes to accept the search method. And let's see how this works. Now, I don't know if this one takes a long time or not, but let's see how it works. Okay, it didn't take long, but it only gave us 3 attributes. These 3, 1, 3, and 4. So it says that those are the only ones that it recommends. Now, I don't think we can choose another search method, or maybe we can. Let's try that, see what happens. Okay, it still worked, but it's 1, 3, and 4 again. So let's try it. So I think we should undo what we did before because I don't know that this were the original one. 1, 3, and 4. I think I forgot to undo what I did. So maybe I should undo that first. Let's undo that first, and then let's try it. Let's see if that makes any difference. Let's run it again. Okay, it's 1, 2, and 3. So this method says that we should only use 1, 2, and 3. So let's delete all the other ones. So the easiest way to do that is click all, and then just undo 1, 2, and 3. And don't forget this one, which you probably might forget. And then click remove. Okay, so now let's try it on that. Again, this is not the point of what we're doing to try it right now, but let's just see what happens. So last time we got 73.1. Okay, so this was a little bit worse. But nonetheless, what we still want to do is save this as a file. So let's see, what do we call this? CFS subset. So let's give it a name like that. So I'll save it as top 3. I guess I could say that, but CFS subset. Okay, just to let me know that that's where it came from. Okay, and let's undo that. And we can keep going. For example, we could try a different evaluator here. And one of the ones that you can try several of the other ones here. But here, I want to try this one called Wrapper Subset Eval. Let's see what that does. And here, what we get to do is, this actually is not just one method, or maybe it's one method, but we get to choose different classifiers to try it with. So what does that mean? Well, for one classifier, like here it's set for 0R, but we could change that to something else. For one classifier, maybe, I don't know exactly how this works, but it sort of tries to focus on one classifier and say, well, what are the best attributes for that particular classifier? So we can actually try all the different classifiers and get many different data sets this way. So let's just choose one. Let's try J48, but you can try many of them. And then click OK, fold, set, seeds. I don't know exactly what all these do, but I'll just leave it at default. And did I undo it already? Yeah, I undid it. And let's try it out. Let's see what happens now. I don't know, did I Maybe I forgot to set the class in the last one, but I'll set it here anyway and use that. I should have probably set the class for the last one when we did this one. We'll see if that makes any difference later, maybe. Anyway, let's do start. We have everything. We have all of them. Let's do start. It's still running. You can see it's thinking down here. Okay, and it finished thinking. And these now are the best ones according to this method. So let's actually try to use them. Oops, can't do that. I have to do Control copy and go back to here. We have all of them. We can go to remove. We can do this. Don't forget to add on 21 at the end, and invert the selection. So we want to make sure that we have, for example, checking and duration, credit history. Okay, so let's see what happens when we run it. Make sure that we have those. So run it up here. Credit direct. Okay, so we did keep the right ones. Okay, and let's go back. This is again not what we're really trying to do right here, but just for fun. Let's see what happens. Let's start. And here we get 73. What did we get? What was the highest we had before? 73.1. Okay, so now we get 73%. Okay, now don't forget, let's undo what we did. Don't forget that you will want to create new derived variables that can also assist in the prediction process or the classification process. So you will have some extra variables in here, and you can, of course, you'll include them and see what these algorithms say about whether to keep them or not. But you should keep them at least for part of the testing that we're going to do. But the algorithms may say to pull them out as well. And you can create data sets that include or you can start with a data set that has your derived variables and then let the attribute selection remove them, or you can start with data sets that don't have your derived variables and see what the attribute selection does. But I do think that we need to include, regardless of whether these algorithms tell us to or not, we should include at least some versions of our data sets should have the derived variables. And by derived variables, I mean ones where we use this filter, for example, the add expression one. In other words, we're taking more than one variable and adding them together or multiplying them together and dividing them together. And by the way, remember that you can create variables that are not just a combination of two variables. It could be combinations of 3 variables, 4 variables, whatever. But anyway, so we should have some like that. But then also when we say derived variables, we also means like normalizing the variables. So you should try data sets where you have normalized and include those in our kind of list here or our collection of data sets. And then other times where you haven't normalized, so where you have normalized and when you haven't normalized. So we're going to create a lot. Each one of these is a data set, right? This one had, I don't know, the top 3, it only had 3 variables in it. This one had the top 3, but something else. And this one had 8, and this one had 10. So we've actually created many different versions of our data set, of our credit card, or I guess it's a credit loan data set. We have 4 different versions here, but we can go on to create, maybe 20, 30, 40 different versions of our original data set in this way. Now, once we have these data sets, we want to use the experimenter. So the way that we want to use it is we click on Setup here, and I think we have to click up here to New. We start with New. So that's kind of what they call a new experiment. And here we have a choice of cross-validation or test train percentage split. We really won't need this. This I use when I'm working with time series data, but we're not working with time series data, so we won't use that here. And we can leave these the way they are right now. And then what you can do is you can add in data sets. Now I have a bunch of data sets created, and I want to add in all of them. Let's see if I can do it that way. Yes. Okay. So I'm going to be working with all of these data sets. And next, I want to add in algorithms. So I'm going to test my data with algorithms. So here I'm going to test with, for example, I'll use 0R, and then I'll add in another one. Maybe I'll try to keep, well, I'll try J48. And then I could also add in another J48, but with different pruning. So I could choose, let's say, 7, or I think at one point he tried 8. Let's see what that does. And then I could even add in another version of J48 where I could say I only want binary splits, so I'll try that. Let's see what happens there. And now I can add in another. Let's try another algorithm. Let's say I want to use Bayes, naive Bayes. And I'll try that. And I won't use multi-layer perceptron right now, but you should. But that tends to take quite a long time. And let's just try one more that maybe we haven't talked about. So we go to a new one. And let's choose, for example, what haven't we talked about? Maybe rules. We haven't done much with rules. So we could try, well, we did actually do some rules. We could do the lazy, but I think they're also slow, so I don't want to do that right now. But I will try, what other trees? Well, here, let's try random forest. Okay, that's a very important one. And I guess we could try linear. One more, linear regression. Let's see if that works. Okay, so now we have a bunch. Now, if you think about it, how many different tests are we going to do here? Well, we have 4 different versions of the data set, and we have 1, 2, 3, 4, 5, 6, 7 algorithms. That means we're running 28 tests, because with each data set, we're going to test it through all of these algorithms. So hopefully, you will have maybe 15 to 20 different algorithms here, and maybe as many as 20 different data sets here, versions of your data set. So you're really going to be testing through a lot of data, and you're going to be running a lot of tests. Maybe we won't have as many as 20. Let's say we have 10 or so, maybe 15. And you don't have to do this all at the same time. You could have 5 here and 5 here, and then a different set of 5 with the same of these, and then a different set of 5 with a different set of these, and so on. So you don't have to do them all together. Now, this is the number of repetitions. So back in the videos in Weka MOOC, he talked about doing the same experiment a different number of times. I'm sorry, a number of times, and then sort of averaging out the results. Well, that's a good thing to do, but right now that's going to take a long time. So I'm going to say number of repetitions is 1, but you shouldn't set it to 1. And this just says which do you want to run first. You want to go through all of the data sets and test them. So I guess that means take this data set and test it through all these, and then take this data set and test it through all these. Or it means, no, I'm sorry, maybe it means that you go this data set, then this data set, then this data set, and this data set with 0R, and then the same thing with this. Anyway, that doesn't matter too much. And now we go to up here to run. By the way, you can change this to advanced and it will show you some more options, but we don't need that. Oh, one more thing here. We are doing a classification problem. Okay. Remember, the difference between a classification problem and a regression problem is where it depends on the output variable. And our output variable is a yes-no variable, or it's a categorical variable. So this is a classification problem. We don't want to do this regression. Okay, so now we go to run, and this could take a while. And one problem is that one of the algorithms or one of the data sets, one of the combinations might fail, and that will stop the whole thing. And it's hard to figure out which one caused the problem. I tried running this many times, and I noticed somewhere I was able to figure out which was causing the problem, but I don't remember where that was. So I just will say that it's hard to figure out uh, which algorithm is causing the problem. But let's see if we can get away with this. So it started. Okay, well, maybe it's not so hard. Weka classifies functions linear regression cannot handle binary class. So I can't use regression for a binary class. So let's just remove that. How do I remove it? I click on here, and I don't think there's anything I can do to change this. So I won't, and I'll just remove it. And let's see what happens now if I run it. That was pretty easy to figure out what was wrong. And let's start again. And it actually finished very quickly, which is sort of surprising, but okay. Let's go to Analyze. And what you do here is you click Experiment. And so it shows you these are the algorithms we were testing. And then we can click Perform Test. And right now we're testing this, which is probably not, we're not really interested in this, but let's change it. Oh, sorry, that's not it. Right now we're using this. So this is what we want, percentage correct. So let's leave it as it is and perform the test. Okay, and now we can blow this up. And we can see all of the different results that we were able to get. And here, I guess, was made, this looks like about the highest one, right? Or this one. And this one is higher. So we found something that worked very well, I'm sorry, that's here. We found something that worked quite well compared to the other ones. This was 76.18%, and that was with using, actually it's hard to see what it was using. Maybe we should switch that around a little bit. But anyway, that was using, which data set was this? I guess these are listed in the same order that they were over here, so we can figure out which data set that was, because it's probably this one here. So it's probably referring to that. I think we can figure that out another way. But anyway, I assume that that's the data set. The name is cut off here, and that is Bayes. Now you also see kind of a V here, and sometimes you'll see a star. And what the V refers to is basically what we're doing here is we're comparing everything with this one. So when something is significantly better than this, it will put a V. So this is significantly better than this. These are all significantly better. However, these are not significantly better, so it doesn't put a V there for these two. But all the others seem to be significantly better than 0R, which is not particularly surprising, right? 0R is kind of the least powerful of the algorithms. But also we might find that some performances were significantly worse, and then you would see a star there. Now, instead of comparing it to 0R, let's compare it to, let's say we want to compare it to this version of J48. So you can choose that here. I guess this is the first version of J48. So you can choose that to do the comparison, and then we can run it again. Now we're comparing to this, and we see some rules are significantly worse than these. We can see that this one is worse than J48. This one is worse, but this one is better. So you can change the one that's being compared, but it's not so important. Really, we're just looking for the highest one. Now, it needs to be said that when you're doing a large number of tests, there's sort of a certain amount of randomness here, and you may find something that is highest. Actually, look, this one is highest, actually. You may find something that's highest just because of randomness. So you may not be able to count on these results being exactly true because we're testing so many different kinds, but we're sort of bound to find something that is high. But we'll sort of ignore that issue, although you should keep it in mind. Now here I think we can switch the rows and the columns, so let's try that. Let's try performing it again. Okay, so now we have, I guess, the data sets on top of it. Still, it doesn't make it easy to read. Oh, here's the key, though. It does give you the key for that now. So now we can see the actual names. Actually, though, these are not the names that we gave them. I thought it would be those names, but that is not the names. Let's go back to here. They don't list the names like that. Inside these versions, if you open them up, I'll open it with this. Or actually, I'll open it up with Visual Studio. But it doesn't tell us sort of how they were removed. This up here, our notation told us how they were removed, but it doesn't show that. Now, it does show that here, but in the printout, it doesn't, unfortunately. So anyway, you just have to figure out which one this one is, which one this one is, this one is, and which one this one is. And also which algorithm worked best. So by doing this, we can go through many, many different tests and possibly really tune up or improve our prediction process. Now, besides doing % correct, there are many other fields that we could test on, or many other things we could test, like % incorrect. We could look at, we might want to see how long it takes we can get the number of training instances and the number of testing instances. Let's just see what that means, perform that. Now we can see that in our data set for training, we used 660, and for testing, we can see that we used 340, so you can get that information. You can get the number correct as opposed to the percentage correct. Of course, we're not really interested in the number correct. We're interested in the percentage correct, but we can see that. And then you could also, there are many other fields here that you can generate. We talked about the ROC curve and the area under the ROC curve. So you could get that as well. Now, when we switched here, rows and columns, now when we see a V here, this doesn't mean how the result compared to a different algorithm. This V means for this algorithm, this was better than this data set, right? The columns now are data sets. So we're saying this was better than this data set, and this was better than this data set, and so on. Whereas if we swap and run the same thing again, now when we get a V, we're saying that this is better than this on the same data set. So that's an important distinction. Now there's one more thing you can do, and that is you can select an output format for this, and you can choose CSV file, and you will get the results printed out to a CSV file. Let's change this back to percentage correct. You can see there are many different calculations we can get. Percentage correct. And let's print this to a CSV file. Okay, let's click on Perform Test Now. Does it tell us where the CSV file is going to go? Not sure where it's going to go, but let's see. Okay, so we get the results are going to look like this. You can see they're comma separated, but I think it should be available to us. Okay, actually though, to get the result as an output, we have to go up to here and choose CSV file and give it, and I guess browse, and I will put it in the same file here, and I will call it results. Okay, and let's see what happens. And let's go to analyze and perform the test. We don't need to perform the test. We just need to click here. Okay, and let's see. Now we have results. And if we open that up, we actually have quite a lot of results here. So we have different removes. It doesn't use the name of the file. It uses the name of the data set, which Weka itself generates. Anyway, here they are. And here we have the different classifiers that were used. And then over here, you can see that we have lots of, for example, percent correct here, and so on. So you can get this output if you want to look at it. And it has all of those different options in here. So it has percent correct, it has percent incorrect, it has a number of unclassified, number of incorrect, number of correct, and so on. It has all of the data in there for the results. Now let's go back and change the number of repetitions. Now that is different than cross-validation. So cross-validation will we can split into, for example, 10 folds. It will run the test 10 times, but it will average all of the results. But when we do it, when we leave this as the way, not cross-validation, but if we change this, let's say to 5, it's going to run it 5 times and give us the results of each outcome separately. So let's try that out. That's going to take a bit longer to run it. And I'm getting some kind of message here saying results cannot access that file because I have it open. So apparently it's trying to write to this file and it can't because I have it open. So I will close it, see if that helps, but it seems like it hasn't. So I have to run, oh, it already stopped, I think. Let's try start again. Okay, you can see it's running through everything. And now it's finished. And now let's look at that CSV file. There's going to be a lot more in there. So here, if I scroll down, there's a lot more because it ran each of the tests 5 times. And then it's also going to give us, in the results, here, let's run it, let's perform the test, percent correct. Let's not make it, let's change the output to not CSV, but just regular plain text. That's what we were using before. Let's run that again. Okay, so it makes a nice table like that. Okay, for some more details, you can go through this tutorial here, which is up here, and you can do a search for this name, and you can go through this as well.